We have a sign that's being hung by cables, and the sign has a mass of 20 kilograms. And here's a cable that's horizontal, and then here's a cable A that's up and to the left at a 30-degree angle, as shown here. And what we want to try to find is, what is the tension force in this cable? What's the tension force in cable B? So let's solve it. There's a very real-world problem. We especially go back east. Have you ever noticed that traffic signs, if you've ever been back east, traffic signs are quite often held up not by poles and beams, but by cables. I don't know why they do that, but they do. All right, so to solve for forces, we need to use the procedure. So I'm just going to take this little spot right here and draw a dot. And the weight of the sign is pulling it down with mg. And then we have F sub B. And then we have F sub A. Okay. So that's, now, so these are all the forces. There's no normal forces. There's no applied forces. There's no friction forces. Look at the problem carefully and say, okay, I got gravity. I got this wire and this wire, all pulling on that spot on the sign. Okay. So now let's define this to be our x direction and this to be our y direction. And so FA is going to have an x component and a y component, and here's theta. So we'll call this FA in the x, FA in the y, and B and the weight don't need to be broken up into components. So now we've done step 3. So step 4, let's sum the forces in the x direction equals MA in the x direction. And then we look at the problem or look at the free body diagram. Well, in the x direction, I've got F sub B, and then I've got minus FA in the x. And that's going to be equal to, well, that's going to be equal to 0. So what does this tell me? Well, it says FB is going to be equal to FA in the x direction. So all FB is doing is pulling to the right because A is pulling to the left, and it's got to cancel it out. That's what that is saying. But I don't know what FA is. I mean, FA in the x is going to be FA cosine, well, theta is 30 degrees. But I don't know what FA is, so I still have to figure that out. So what I'll do is I'll sum the forces in the y direction equals MA in the y direction. So I'll do that. And in the y direction, I've got FA in the y minus mg equals 0. I get that from the free body diagram. Look, this force is in the y direction, this force is in the y direction. That's all I got. And there's no acceleration in this problem. Well, this tells me that FA in the y is equal to mg. But FA in the y is equal to FA sine of 30 degrees equals mg. So FA is going to be equal to mg divided by the sine of 30 degrees. So that's going to be 20 kilograms. Mg is 9.8 newtons per kilogram. Divided by the sine of 30 degrees, which is 1/2, so you basically take this and double it. And from that you get FA. And what is FA? What is it? A little less than 40, isn't it? 30? Or wait, 20 times 9.8 is what? 196. Oh, yeah, that's right. I'm sorry. 196 divided by 1/2 is a little under 400, right?
Yeah, 392.
392?
Yeah.
I was trying to do it in my head here, but well, that's one of my answers. Now, what is FB? Well, I look up here, and FB is FA cosine theta. So FB is equal to FA, which we got to be 392 meters, or I mean newtons, times the cosine of 30 degrees. And so we get FB is equal to what? What is 392 times the cosine of 30? 339.48?
Yes.
About 339. Let's round it off to that. If you want to put the 0.5 or 0.48, that's okay. Okay. Let's zoom out so you can see the whole problem. So, again, you're just doing the 5 steps, and but I kind of let the problem tell me what I need to do next. You know, I mean, I just recognize, oh, this is a force problem, so I got to draw a free body diagram, and oh, I do have a force that's got x and y components, so I draw those. Now, start off in the x direction, sum the force in the x direction. I got FB minus FA in the x. And then, oh, well, FA in the x is going to be FA times the cosine of the angle. But I don't know what FA is. So I've got 2 unknowns in here. So that just means, hey, I'm not done yet. I got to find out what FA is. So I look in the y direction. Let's look in the y direction. And the y direction allows me to solve for FA. Then I go back to what I started with over here. FB equals FA cosine theta, and I get it. Any questions? Yes?
When you were summing up the y forces, how did you go from FA y equals mg to FA sine 30 degrees equals mg?
Oh, so the question was, how did I go from this line to this line right here? Right. Well, this is FA in the y direction, so I looked up here, and this is FA. This is the vertical component. So FA in the y component of FA is equal to FA times the sine of the angle, because it's the opposite. This is opposite of that angle.
Okay.
So one of the things to remember, right, if you have a right triangle, you can take, if this is theta, and we'll just call this, you know, FA, even though I know FA was in the other direction, doesn't matter. This is FA in the x, and this is FA in the y. This could be any, what is cosine theta? Cosine theta, by definition, is the adjacent leg divided by the hypotenuse. Right? So what I can do is to say, okay, the x component of this vector is equal to FA times the cosine of the angle. I just multiply both sides by FA, and I get this. And FA in the y direction, sine theta, by definition, is the opposite over the hypotenuse. Well, in this case, the opposite is FA in the y over FA. And so FA in the y is equal to FA sine theta. Now, remember, these are determined by where the components are with respect to this angle right here. Sine and cosine are defined to be, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. And so, like, what if I gave you, what if I had taken this problem and given you this angle right here, like this will obviously be 60 degrees, right? Well, you know, this component would be FA times the sine of 60 degrees. Well, the sine of 60 degrees and the sine of 30 degrees is the same thing. But so you have to pay attention to where the components are with respect to the angle, whether you're going to use sine or cosine. Any other questions? Yes?
The other thing I noticed, though, is that we're doing right triangles again. Are we allowed to even think of the 30, 60, 90 rule again about like
Yeah, you can do that.
hypotenuse is 1 and then FA right there, Y would be 1/2. So
Sure.
if you found like 196, then you multiply it times 2, so you get the F of A, and then
Sure. I mean,
I'm probably not going to do that though in this class.
well, I mean, so the question was, you know, can we use the things that we memorize about, you know, 30, 60, 90 triangles and tricks? Sure. I mean, I know that the sine of 30 degrees is 1/2. And so I don't need to use my calculator to figure that out. You can memorize it. But, I mean, what if I had given this as 34 degrees? Then you got to just plug it in and use your calculator. That is all.